In this video, we will go through an example of using the first and second derivative tests that we learned about in the last video. So here's a function. F of x is x to the fourth minus 2x squared plus 3. In order to use either the first derivative test or the second derivative test to find the relative extrema, which would be relative mins or relative maxes, we first need the first derivative. We can't do either the first derivative test or the second derivative test without knowing the critical values. So we need to know when f prime of x is equal to 0, which means we need to know what f prime of x is. 4x cubed minus 4x, which we can factor out of 4x. And then we can factor that x squared minus 1 is x plus 1, x minus 1. And so we'll find that the zeros are when x equals 0, when x equals negative 1, or when x equals 1. So if we want to find, using the first derivative test to find out if there's a relative min or max at any of those 3 points, what we're going to do is check the signs of the first derivative on either side of all of those critical values. So we'll do that with a quick sign chart. I'm going to put my x values up here. I've got negative 1, 0, and 1. And for my f prime of x, all I really care about is whether it's going to be positive or negative. So when x is less than negative 1, we have a negative, and a negative. So all 3 of those signs are negative, which means that f prime of x is negative. When f prime of x, or when x is between negative 1 and 0, this factor becomes positive, while the other 2 are still negative, which means that the 2 negatives cancel each other out, and f prime overall is positive. Once we pass 0, this factor, I should say, becomes positive. This one was already positive, and this one is negative, which means the 3 work together to make a negative f prime of x. And if x is bigger than 1, all 3 of these factors are positive. And so f prime of x is positive. Which means that since f prime of x switches, and you got to use this language, switches from negative to positive at x equals 1 and negative 1, there is a relative, or there are relative mins at x equals 1 and negative 1. And then the flip side of that is almost the exact same sentence, but switched around. Since f prime of x switches from positive to negative, at x equals 0, there is a relative max at x equals 0. Okay, so make sure you say that sentence the whole way. It's worth pointing out that a sign chart is never considered justification. The AP problems that ask about this will always ask you to justify your answer, and showing them a sign chart won't do anything. They won't even look at it. The flip side is if you do the sign chart wrong but put the paragraph the right way, they won't take off for writing the sign chart wrong because they won't even look at it. Okay, that is the first derivative test. Using the second derivative test, we would still using the same critical values, so we still need to do all of this to find out when f prime of x equals 0. What we want to know is what is f double prime of x at all of those values for x. So we got to find f double prime of x, which is the derivative of f prime of x, which is 12x squared minus 4. And so what we care about are f double prime of 0, f double prime of 1, and f double prime of negative 1. So f double prime of 1 is equal to 12 minus 4. F double prime of negative 1 is also equal to 12 minus 4. And f double prime of 0 is equal to 0 minus 4, which is negative 4. And so we can see that f double prime of 1 and negative 1 is positive. So since f prime of 1 and f prime of negative 1 are both 0, and f prime of 1 is positive, and f double prime of 1 is positive, and f double prime of negative 1 is also positive, those are the two conditions, that the derivative must equal 0 or not exist, and the second derivative must be positive. That is enough to say that there is a relative minimum relative minima x equals 1 and negative 1. And then we can also say, since f prime of 0 equals 0 and f double prime of 0 is negative, there is a relative max at x equals 0. Just a quick note about the language of the problem here. The question asked me to find the relative extremes. That means find the relative mins and find the relative maximums, which means it really does want the y values also. So just be careful about that. If it asks for the maximum value or minimum value, it specifically is asking for the y value. If it asks for the relative minimum or relative maximum, without using the word value, it's probably asking for both the x value and the y value. So in order to find the y value, we would just have to find what is f of 0, f of 1, which is 1 minus 2 plus 3, and f of negative 1, which is also 1 minus 2 plus 3. So now we would have the relative mins and maxes.